Alright, we are live for a CSC 240 review. Alright, we are live for a CSC 2... Seems like my voice is coming through just fine. So I'm going to I want to take a poll to see if we've got any viewers. There it is. Real quick, I want to see, do we have, if you are viewing the stream for object-oriented programming, go ahead and talk in the chat box, and I'm going to gauge to see if we are still on for the stream, just by gauging how many people are actually watching. Oh, great! So we've got Mesnek is here, and you want to, since Mesnek's here, then I'm just going to go ahead and get started. As we continue, I'm sure more people might show up, but if not, no worries. We can just cut it short. No biggie. So you want? Let's start. Let's start with requests. For Mez, did you want to see anything in particular regarding object-oriented stuff? Go ahead and place requests. I'm going to actually make a note. Cool. I'm going to keep chat on my right. Keep chat full screen on my right. Let's do something here. Let's do... see what we got here. See what we can mess with. .240 review. That was in C. Let's do a C. Let's load a C++ example. Yeah, this is what I did for the lecture exercise. This actually is valid. This actually could work. Perhaps it behooves us. Yeah, Mez, I kind of figured you were set from our previous discussion. You seemed like you had a really good grasp on it, especially since this is kind of a late stream, given the topic is already past. But I figured what we're going to do is we're going to cover it from scratch and do it anyway. Just because I figured that as we approach the final exam, what's going to happen is students are going to look for assistance, recapping stuff, and so there we have it. So what we'll do, let's do a int global ID. I'm going to actually take, let's go to, I'm going to delete this file, but I am going to back it up before I delete it. Cool. Alright, so now we're going to do all of this. We're going to get rid of all of this. I'm just going to erase all of this. And we're just going to start from scratch. Save all. And you'll notice if we run, it'll compile, and we get the console. And so we've got a nice starting point, as usual, to work in Visual Studio. Yeah, Git for the win, indeed. So Actually, it's kind of weird. I'm actually in horrible habits. So my horrible habits are as follows. I usually do projects. I'm used to doing projects locally, and I'm just not in the habit of committing my personal projects to Git. But that's actually something I just recently started getting into, just because it's I've had one or two headaches, and then I don't want to have those headaches anymore. So there's that. But yeah, I'm just for a while I've just been doing stuff locally, just because I don't want to be sloppy, but it's not exactly the best practice. So let's create a class, and let's create. Tell you what. Let's do an example for all those object-oriented folks to come back to when they need it. Let's do a pattern matching example. I think that'll be fun. We're going to do a pattern matching example, and here's what I mean by that. Let's do class. Let's call it. It's going to be an interface. Let's do that. Let's do pattern matching. Why not? And what this will have, if I remember my pattern matching structure here, let's see, it's going to have, let's see, what we need, obviously, we need something in order, we need something, so we'll do something like this. We'll do public void, public void update. Oh, I don't think it likes that. Oh, right. This is not C#. There we go. All right, cool. So we will create a method for update. So all nodes have to be updatable. And let's actually do I feel like I have a reference on how to build this. Let's see. Got about 3 people watching. All right. Feel free to request object-oriented topics if you'd like, if there's anything specific. But let's take a look at, where's my index for code project cap. All right, here we go. Let's see here. This is something I worked on previously for something different. That was it. Take next input. That is what, and it takes an take next input, which takes a pointer to a weak pattern node. All right. Virtual bool take. I knew it was something which takes an pattern node pointer 0. That's pure virtual. I think actually, yeah, okay, I made it pure virtual. VM. Right. Okay, I see. Inserts a new node into the current pattern. So we can configure pattern virtual bool. What was that? Was that bool? I don't think that was bool. No, yeah, that was void. All right, void. Configure pattern, which takes also a that's right. Reset, need a reset. the common interface for reading in a pattern one element at a time. Let's see. Okay. Okay, cool. All right. All right, so now let's work with this, and I'm gonna oversimplify the example. So what we're gonna do is we have created a very basic interface, So this is a class called Invoke Pattern node, and usually in practice you'll preface your interfaces with the letter I. And what this is like as we talked in class that day on the lecture exercise. This is a specification for any object that inherits from Invoke Pattern node has to supply implementations of these methods if we want it to be instantiable. Now, if we're not going to instantiate it and just use it as another abstract class, or interface, then we can leave some of these as pure virtuals, which is their methods set equal to 0. In that case, that's acceptable. But if we want something to be actually used, then we have to implement all these methods, because in practice we expect the ability to use these, although their implementations may be different across different objects. So now, an example of this might be something like this. I'll go back to my reference here, and we've got weak pattern. Let's do n occurrences, n elements. Let's do this. This is an easy one. N occurrences from elements. So then so notice in weak pattern node, this was the foundation in our example for building up patterns. Here is a specific node here, so n occurrences of element, right? And it inherits from Invoke Pattern node, and so then it says this. It says pattern node that does not trigger until the provided element is matched n times. All right. So that means you give me an element, and we count how many times we see it, and when we've seen it that many times, then we trigger this node as occurred. The node has occurred. So this is a very, very straightforward implementation. We just have the actual element that we're detecting, and then we have the target, and we have the current. What we're accounting to. So it's just a simple counter. So then we have weak pattern node, and we're going to say, all right, so now I want a class. I'm going to call it n count. I'm going to just change the name. N count. No, I like it better. N occurrences of element. N occurrences of element inherits from Invoke Pattern node, and that will be that class. So now what I'm going to do, so now here I'm going to actually declare n occurrences of element e. I'm going to declare it in main, and you're going to notice error object of abstract class type and occurrences of element is not allowed. There's no overrider, C for pure virtual functions, and literally it's telling us right there that there's no overrider. We can't do anything with it. So because of that, we have to provide something. So what I'm going to do is I'm going to provide just the basic building block for it. I'm just going to say bool take next input. And we need to give it a privacy modifier. Here we go. Now if we look at it, you'll notice one of the methods disappeared. So now we can do it again. We'll say void configure pattern, takes an Invoke Pattern node. We'll call it n again. Do that, and then we'll say void reset node, and we'll do that. And now look, long behold, the error has gone. The error is gone, and we can now build this. But you'll notice there's build errors. There's still build errors. Would you like to continue run the no? Let's see what's going on. Oh, so it was just a basic one. N occurrences of element, take next input must return a value. Okay, so take next, and we'll just return true. So now if we build it, yep, and sure enough, it builds and it runs fine. And it's using a default constructor, which we don't have an issue. We're not really using variables here. So you can see, so this is actually really cool. This is kind of cool in object-oriented programming. We have this interface, and we say that n occurrences of element implements this interface. And it's got definitions for that interface, despite the fact that those definitions happen to be empty. Now what we can do is we want to extend, we obviously want this to be interesting, we want to extend this a little bit. So in order to extend this, let's see, we obviously need something, that we need a terminal element that defines how we actually make a comparison. You'll notice here back in my weak pattern node, we have booleans for strict mode. I'm not going to worry about in this tutorial. Is configured is actually really important. The first time, yeah, I'll get to that. And is it locked? And I'm actually going to keep this as simple as possible. So I'm actually going to make some assumptions about this. Take next input, get configured, get locked, insert symbol. Rejected. Oh, that's interesting. Okay, cool. Alright, interesting. So let's do this. Let's pull up another instance of this. Let's do n simple element, and yeah, let's do n simple element. Open that. There we go. So n simple element. So n simple element implements I weak pattern node, and this is wrap a character to be used as a terminal symbol in our pattern matching system. So we wrap, and notice I'm using the Qt framework. Don't worry about that. The variable names are going to be weird. They're just going to be. So you'll notice in our simple element, which I'll go back and implement real quick, you're gonna notice a couple of things. Class n simple element I weak pattern node, and let's terminate that. And we're gonna notice a couple of things in this simple element that it's interesting. Configure pattern and reset node don't have implementations. That's because there's nothing to reset. And take next input is actually going to just compare for equality. So it's going to perform a cast on an element that was given to us, and it's going to dynamically cast it and make sure that there's equality, that there's an accurate equality check. So what we'll do, configure element. Let's do this. Let's make this. Let's say an n simple element is going to have a. Now it has some part of it. It has private. There's some private stuff now. So private stuff is just going to be a. It's going to have just a char. We're just going to give it a char called C. We'll give it a char, and then we'll give it a public interface that we need to work on. And I'm actually going to give it also a protected interface. So we're going to say, what's protected? Configure pattern. And reset node. They're not going to do anything. They are not going to do anything. And in n simple element, I'm going to make them hidden to the public because there's no reason to call them. Although you might want to do something with them in a child of nSimple element. That's a possibility. And then in public, I'm going to create a constructor. So nSimple element. nSimple element is going to take, it's going to take a character as input. We'll just call it P. It's the parameter. And all it does is it just says that our character is P. That's it. We just do a simple assignment. That's all we do in the constructor. And then what we will do is then we will implement our take next input. And we will say, all right, so bool take next input. It takes an iWeak pattern node. Let me see how exactly this does how it does this. How exactly take next input. Right. If the next element is not null and this character element is the next element. Oh, I see. That's what I did. Okay, cool. So I actually did a cast. Alright. Take next input and so what we're going to say, essentially, we're going to say, all right, we're going to say that, what is this, nSimple element? So nSimple element pointer, S is our simple element. It's going to equal, I think we can do, can we do dynamic cast? I think we can do dynamic cast. Real quick, let's double check, make sure we can do that. Let's make sure this is going to work. Blah, 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 dynamic cast. Okay. Okay, cool. No, yeah, we're definitely going to use pointer type. Good, it'll throw null, so then we can handle it. Cool. So real quick, just for the folks watching the stream, I'm going to give you guys a quick explanation of the cool dynamic cast feature in C++11. So if the cast is successful, dynamic cast will return a value of type new type. If the cast fails and new type is a pointer type, it returns a null pointer of that type. And then if the cast fails and new type is a reference type, it throws an exception. So this is good. So since we're working with pointers, this is good because now if the cast fails, we can deterministically switch our return value to true, which is good. So this is good. So dynamic cast, and I believe the way the syntax is, it's dynamic cast, new type, and then expression. Okay. So dynamic cast, the new type is going to be, n simple element, and we want to give it n. Oh, whoops. Yep, my bad. There we go. That works. So dynamic, it uses pointers and stuff. So what we do is we have this pointer to a weak pattern node, which is a more abstract version of nSimple element. Essentially, a pointer to iWeak pattern node, we only know three things. We only know that these three methods, whatever that object is, it must implement those three methods. That's all we know. So because that's all we know, we're going to do a dynamic cast that's going to attempt to take this element and say, oh, is it really a simple element? Meaning, does it have the variable char? Does it have everything we need to make our program work, to make it behave like an n-simple element? If it does not, S will be a null pointer. If it does, then S will point to the valid object type. So this is good. So then we can do something like this. If we can do something really cool like, let's say, so if n-simple element, that's, no, let me say that, if S, and also pretty much when you use a pointer, it just uses it like an integer, so as long as S is not 0, so if S, and, so if S and this, the character here equals let's make sure so this character equals S's character. There we go. So then we could just simplify that. Let's simplify that to this. That's it. Cool. Yep, it should like that. Yeah. So it's just going to return this Boolean value. It will make that comparison, and it will do that work for us. And then it just saves us some syntax, and it makes the method very easy to understand. And that should do that. So now, how do we test this to make sure that this is actually working? Well, then what we'll do, and we'll come back to n occurrences of element. So we'll let's create a couple of simple elements. So let's say n simple element we'll just call it e1. You want let's use pointers. E1 equals new n simple element, and we're going to give it a character. Let's say we want to give it, let's give it T. Cool. And then let's do, and now notice how we're just wrapping a value. See how this whole class is just wrapping a character? So we're giving the actual comparison value extra data so that there can be extra functionality to it. N simple element E2, new n simple element. Let's give it B, right? And there we go. So now, here's the cool thing. So now what we're going to do is we can actually print, what I'm going to do is we're going to create a very small system that will actually scan through all of these, and as I input characters, I'm just going to keep inputting characters, it will validate a pattern that we build. It will validate a pattern that we build. I'm going to take a quick check to make sure there aren't any questions. All right. Now I'm going to continue. I'm going to make it real quick. You might hear an echo. I'm going to check my audio. It will validate a pattern that we build. I'm going to take a quick... All right. Audio looks good. Stream health is good. I'm actually really happy we managed to get this on 1080p. That makes me very happy. 1080p. And then what we'll do, now let's see. So we've got this. So let's go back to our weak pattern node and make sure that we give it what we need. So let's see. Rejection conditions, weak pattern node, take next input, configuration lock. I believe we are going to need we're going to need to configure it. We are going to need to configure it. So let's do unless we're configuring with our constructor. That's essentially what we're doing. Yeah, we're essentially saying we're configuring using the constructor. So that works. That actually does work. So now let's do this. So now let's do n occurrences of element. N occurrences of element. The constructor for this will look like this. So we'll say n occurrences of element, and we're going to construct it with, let's see, we need the element, obviously. We need the element, obviously. So I weak pattern node, and so we need the node that is going to serve as the element that we're keeping track of, and then we need an integer count. We need to know how many do we want to find? How many of these do we need? And then what we'll do is we need that in memory, so we'll just say private, and we'll say I weak pattern node, and we'll say, call it node, and we'll call this integer, I'm going to make that C, I'm going to make this count, I'm actually going to make this target count, int current count. There we go. Cool, everyone's happy. So now, obviously, so then node will be initialized, so then, and we have to make sure it's not null. You want to know what? It's an example. Normally, you'd make sure nothing's null, but in this case, I'm just going to skip over that. So we're going to initialize the node. We're going to initialize our target count. So target count equals the count we give it. Target count equals count, and then we're going to initialize current count. This is important. Make sure you initialize it to 0. And that's that. All right, and after we do that, we're going to override take next input. And we're going to configure the pattern. The configure pattern, we can actually, we don't need that because the constructor is enough to configure this pattern. So we do not need to configure it. The constructor is enough. So I'm going to create a protected block, and I'm going to move configure pattern up to the protected block because we don't need it, but maybe a child needs it. We're not sure. And reset node. Now we can reset the node. Resetting this node is actually quite easy. All we have to do is set current count back to 0. So we'll just do current count equals 0. And that's enough to reset our node. If we're tracking a pattern and we're counting the occurrence of a character, this is enough to reset the node. And then now take next input. This is going to take a little bit more. It's straightforward. We're going to do an I weak pattern node. All right, so we're going to take an I weak pattern node, and then we're going to take it. We're going to condense it to we're going to actually invoke its method. So we're going to say we have a weak pattern node. We're going to say n dot take next input. And we're actually going to do this. We're going to do if n take next input n. So literally, it's kind of weird how we're doing this. We're actually passing the object to itself, but it's going to take care of everything we need. It does the unboxing. It does the unboxing here, which this is actually very handy. This is kind of a cool trick. Here, let me finish this sentence, and then I will explain why exactly this is so neat. Cool little code reflection trick. And take next input. So if it returns true, then we're going to say current count plus plus. That's it. Now, the actual truth of this node when it returns true is different. If current count equals target count, then we can return true. And we'll have to do a couple of things actually before we just return true. We'll have to do a couple things. We'll have to reset. We'll have to reset this node, and then we can return true. Otherwise, we can return false. And so that's cool. So there we go. So now we've got a natural extension of our interface using a couple of objects. We've got this n occurrences of element that will track the given node and will increment using this strategy. Notice how we use n, so the node we're giving it, because keep in mind, a node, an object, contains not only values, but it also contains logic. It contains its own logic and system. So we're passing itself to the object, hopefully to get to, in this case, what we're going to get back is we're going to then do the cast. Because then, let's say we create a different type. Let's say we create a different type of terminal node. Instead of n simple element with a character, what if we had something a little bit more complicated? What if we had a n complex element with a whole list? Well then, naturally, we could implement this differently, and then this object and occurrences of element still works. We don't have to change this code. The code still works. All of the unboxing and casting gets done here, and then this code can stay the same. So that's why we're doing this kind of weird shortcut here. It just makes it so that our structure is long lasting and endurable, and it's just at least in our case, this is a really good practice for for the example. So now we can test this. We can say, now we need, of course, we need a way to configure, and I need to jog my memory of how the heck. We have rejection conditions. Let's see. Let's see. Okay, so here's the cool thing. So now let me point this out, and this is a direct consequence of our interface and our inheritance hierarchy. So try this. Notice when we don't need to configure. Why? Because we are configuring in our constructor. The constructor so far has been enough to configure our node. We don't need, just if the constructor works, then great, just keep it simple, use your constructor. So in order to configure the node, we need n, and we need c. And so now we'll notice that to configure all of this, when we construct something, so right now we have two nodes constructed, and if I were to use the the syntax we defined, I could I can define a bool, b1 equals, I'm going to go bx equals e1. Take next input. What are we going to give it? We're going to give it a weak pattern node. We're going to give it E2. Cool. Oh, but it needs more. It needs more, doesn't it? Oh no, that worked. That should have worked. E2. Why doesn't it like it? Oh, right. Quick tip. Yep, that did it. Okay, quick tip, guys. In C++, there is, and I completely forgot about this, but it's very important. There is privacy in inheritance. Yeah, there's privacy in inheritance. So you want to make sure that when you inherit, and you're going to be freely jumping between the objects, you want to make sure you inherit publicly. Make sure the relationship is public. Public inheritance. It's important. If you're going to be doing a lot of polymorphism, if your application calls for it, you'll need that. So we'll do that, and then we will do bool by equals e1 take next input, and we'll give it E1. Okay. And then what we will do is we will do cout bx. Or maybe we'll do something. We'll do printf bx. There we go. So you can see. So you can see the result. You can see the result of what we've done. So we've given the input of our structure to, we've given this. We're using E1. We've given the input of our pattern matching. We've given them different nodes to consume, and then these nodes have gone through this hierarchy. And then now you can see what has happened. So we've given these objects the values, and you'll see only for by does it return true. So now notice this is overly simplified. This is very simple because this is only the base case. But now what we can do is we can actually, watch this. So now I'm going to declare a n occurrence. So n occurrences of element, and this is occurrences, so I'm going to use a pointer and say O1. We're going to give it new n occurrences of element. And now I'm going to actually make my code neat, and then we're going to give it the parameters it needs. So it needs a pattern node. So what node are we gonna do? Let's give it E2. Let's say E2 is going to be the node. And how many times? Let's say we want to see it 3 times. Okay. Cool. So now what I'll do is now I'm going to printf a lovely little line, so nothing else gets in our way. So you know we're on a different block. And now we're going to say, all right, so watch this. Let's just do this. Make this easy on us. For int I equals 0, I is less than 5, and I plus plus. This will be very interesting. We will just do this. O1, take next input, and what are we going to give it? We're going to give it we configured it when we constructed it. It says it's expecting an E2 3 times, so let's give it E2. Let's give it E2. And so now that's gonna execute. That's actually going to execute 5 times. So now let's see what we get. Oh, and there you go. So there it is. So now you're starting to see what how dynamic our structure is working here. So this is kind of cool. I'm dumb. Not paying attention. Okay, here we go. So we have the original case. Now you notice we created R, and now notice the first time 0. So now notice the method hasn't changed. It's the same method, but notice the first time false. It returned false because it hadn't reached its quota yet. The next time it returned false because it hadn't reached its quota. But on that third time, which was what we told it to expect, on that third time it returned true. But then here's the cool thing. based on the behavior, the defined behavior of our interface. We said these three things need implementation. And then we defined them in our children. So because of that definition, notice then it resets. All right, now it's looking for it again. So now if I were to make this 6, let's make it 6 now. And there it goes. Then it goes again. So it saw it 3 times, it saw it 3 times, and then it saw it another 3 times, and then it registered the match. So match and match on these instances right here. And that's because this structure is really flexible. This structure is really flexible. It lets us do a lot of really cool things because we're defining what the rules of what this structure should have. But wait, there's even more. There's even more. What if I did this? What if I did this? Check this out. So now let's do n occurrences of element. We'll call it O2. And let's get implement new n occurrences of element. But now what I'm going to do is I'm not going to give it a simple element. I'm going to give it n occurrences of element now. So I'm going to give it O1. And I'm going to say I need to see it twice. I need to see 2 occurrences of O1. And that's it. Excuse me. So that's what I'm going to do. And then what I'm going to do now on top of that, so now I'm going to O1, no, I'm going to say O2 take next input. And it's going to take E2. So let's see what happens here. Well, this is interesting. So this is interesting. So now notice that n occurrences of element, it's expecting 2. It's expecting 2, and we initialized it. We initialized it with O1, right? So we initialized it with O1, and O1 was initialized with E2. So you'll notice we've got so it's expecting it twice. So it's triggering every other time. But so there's obviously something wrong, because what we need to check is that here, right here. So O2 take next input. So we need to make sure that we got to see what's going on here. Maybe I'm plugging it in wrong. Let's give it a. Let's see what's going on here. N occurrences, simple element, gave it a C. Which means this should not return. So this has the character that's been wrapped. It has the wrapped character. It has the logic. So this guy's good. This guy's wrapped. This guy should be good. So something is happening here. So right here in the n occurrences, we've got the node, we've got the target count, and the current count. We did the initialization right. Take next input. So if that node take next input n should return true. But the thing is, we gave it another polymorphic version of itself. So this shouldn't be. That's not what should be happening. We gave this guy O2 is a new n occurrences of. We gave it O1 as what should occur. O1 is what should occur twice. The problem is here we are giving it E2, which means it should occur 3 times. So we're saying we want to see 3 occurrences of E2 twice, which means it should be 6 occurrences of E2. So then for some reason what's happening, it's 1, 2, 3, 4, 5, 6. This is where the 1 should be. These should not be 1. So we've obviously got a bug. So now we're going to hunt the bug. If current count equals target count. So bool take next input. we'll take next input. If n, take next input, give it n. Aha! That's the problem. That's the problem. This should be node. That's why. That should be node, not n. That should be node. So the node we have should be given that next input, that next node. And then this node will tell us. That's why it hasn't been worked. So that was the bug right there. Originally that was n and we were doing a little reflection thing. That is a bug. That should be node. The node that we initialized it with. That was the problem. So now we run this again. And now it works. And now it works as it should work. Now it works great. So what it does, so this is cool. This is pretty cool. So using an interface, using an abstract class, what we've done is we've created two types of classes, and now using this cool little self-reflection rule set, what we've done is we've created a pattern matching structure. And this pattern matching structure could be serialized to any form of metadata you desire. XML, JSON, anything you want. It can be serialized to and then loaded. The patterns can be loaded, and then you can have events fire when you detect patterns. So that's actually really neat. So just a recap of what's going on. We created n occurrences of element, 3 instances of E2. Here we created n occurrences of element, 2 instances of O1, which is 3 instances of E2. So if you do the multiplication, that's 6 instances of E2. And you can build these cool structures out of each other. It's really neat. As long as you implement, all it takes, you need to implement these 3 methods correctly. And if you do, the structure should work. The structure didn't work because what we did is we found a bug in our code that, and ironically, with no surprise, the bug was in one of those key methods that we had to implement properly. Now that the methods are implemented properly, the whole structure works. And once again, I'll show you. So it's getting the next it's getting that input, and then the pattern is recognized on the final one. And that's how it goes. Okay, so real quick, so what I'm going to do is I want to open up the floor for questions. And let's take a quick, take a 5-minute break because I am at 6 p.m. right now. An online test is unlocking for me. I'm going to keep the stream going, so I'm still going to be in stream, but I want to just take a quick break so that I can real quick do this online test. And then what we'll do. If there's no questions, then we might end early, or we might go into something else. But please, if you have questions, go ahead and throw them in chat. I will make a note that at 52, so around 52:30, I have to cut out some time. Cool. Yeah, let's do that. What I'm gonna do is I just between Mesnek's comment and I'm looking at this test, and this is a non-trivial question. It's a one-question test, and it's very non-trivial. So what I'm going to do is let's go ahead. Let's end early. Let's end early. But as a discourse for ending early, yes. In response to Mesnek's request, I will most definitely be posting my code on Blackboard, and I will make sure I make an appropriate announcement when that has been done. So yeah, let's close it up for today. That was great. I'm very happy we got the stream up to 1080p, and we will resume. We believe we have a stream on Friday, so on Friday we will cover Scheme and some other stuff. There are also some other topics. There are also some topics we didn't get to this stream because of low attendance. So what I will do is I will move those questions as well into Friday, and we will address them. Stuff like design patterns, maybe more on polymorphism, and definitely binding. We have to address binding. Binding was requested, so Friday we'll address binding as well. And yeah, we'll call it there. All right, guys. Thank you for watching. Hopefully we will see you online Friday.